Let us solve the inequality. So we write this inequality as inequality 1, and further we observe that this quantity has to be non-negative or greater than or equal to 0. So square root of log of x with base 2 minus 1, it has to be a real number if log of x with base 2 minus 1 is greater than or equal to 0, which is true if log of x with base 2 is greater than or equal to 1, that is x is greater than or equal to 2. So we assume x is greater than or equal to x is greater than or equal to 2. Okay, so when we take x greater than or equal to 2, we find that this quantity remains defined. What about this one? You see that we have got log with base 2 and log with base half. Can we simplify it? The answer is yes. Further, log of x cube with base half. You see that powers can be taken out of logarithm, so that's equal to 3 times log of x with base half. We simply use the formula log of a to the power m equal to m times log a. We are taking powers out of the logarithm. Okay, fine, but further still we are having base 2 and base half. You see, still we are having base half. Can we simplify it? The answer is yes. Let log of x with base half be equal to u. That implies half to the power u equal to x. We cross multiply it. 1 equal to x into 2 to the power u. Let's take log with base 2. So log of 1 with base 2 is 0 equal to log of x with base 2 plus log of 2 to the power u with base 2. So we can write this as 0 equal to log of x with base 2 plus u. And so we can say u equal to minus of log of x with base 2. But what was u? u is log of x with base half equal to minus of log of x with base 2. Okay, now we can write inequality 1 as square root of log x minus 1, we copy as it is. Square root of log x with base 2 minus 1, we copy as it is. 1 by 2 log of x cubed, that's equal to 3 by 2 plus 3 by 2 log of x with base half. But as we have seen, log of x with base half is minus log x. So minus log x with base 2 plus 2 as it is greater than 0 as it is. Now we need to simplify this expression. So far we are assuming x to be greater than or equal to 2, but we have got a square root. Let's remove that square root. We simply assume square root of log of x with base 2 minus 1 equal to t. That gives us log of x equal to, if we square it, t square plus 1. So this inequality can be written as t minus 3 by 2 log of x is t square plus 1 plus 2 is greater than 0. Let's multiply it throughout by 2. So if we multiply throughout by 2, we obtain 2t minus 3t square minus 3 plus 4 is greater than 0. So we simplify it further and write minus 3t square plus 2t plus 1 is greater than 0. Let's multiply this inequality by minus 1. So we obtain 3t square minus 2t minus 1 is less than 0. Now you see that left hand side can simply be factorized by splitting the middle term. So the middle term is minus 2. Minus 2 can be written as minus 3 plus 1 and minus 1 as it is. We take 3t common and we are left out with t minus 1. Take 1 common, left out with t minus 1. So we can write this as 3t plus 1 into t minus 1 is less than 0. If I take t less than minus 1/3, then this quantity is negative, and this is also negative. Negative into negative is positive, but we are less than 0, so not possible. Further, if I take t greater than 1, then this is positive, and this one is also positive, so that is also not possible. So I cannot take t less than minus 1/3, and I cannot take t greater than 1. So t has to be less than 1, and t has to be greater than minus 1/3. So that is the only possibility. But we are assuming t equal to square root of log x minus 1. So that implies minus 1/3 is greater than square root of log x with base 2 minus 1 less than 1. Of course, this quantity is greater than or equal to 0, so it's not possible that it will be minus 1/3. In fact, it will be greater than or equal to 0. So log x with base 2 minus 1 is greater than or equal to 0, and it has to be less than 1. Let's square it both sides, or squaring throughout. So 0 is less than or equal to log of x with base 2 minus 1 and less than 1. Now add 1 throughout to obtain 1 is less than or equal to log of x with base 2 is less than 2. Now we can say that from here that if a log of x with base 2 is greater than or equal to 1, then x has to be greater than or equal to 2, and here it has to be strictly less than. Log of 4 with base 2 is 2, so it has to be less than 2, less than 4. Therefore, final answer is x belong to closed interval 2, open interval 4. It belongs to, these are all the real numbers that lie between 2 and 4, including 2.